I hope all of you had a very joyful and happy vacation. Okay, then let us get back to our work.
Sir,
Yes.
sir, last class I wasn't able to attend last physics class, sir. I checked the notes and recording. I have
Uh,
one doubt, sir.
uh,
Sir, what is the derivation for the fifth kinematic equation, sir?
it is like what you call empirical kind of derivation. Displacement is what is fifth equation? Displacement equal
Sir,
to u plus v by 2
yes.
into t. Displacement is average velocity into time. If velocity is changing with time, then you take average velocity. Average of initial final velocities is u plus v by 2 into t. That's all. It's a
So the
direct kind of equation.
displacement formula is average velocity into time, sir.
Displacement is velocity into time if
Okay,
velocity
sir.
remains constant. If velocity changes,
Okay,
then you
sir.
take average velocity, initial plus final by 2.
Yes, sir.
Sir,
So,
so we know
uh,
that velocity equals to displacement by time. So time goes to the other side, it will become velocity into time equals to displacement,
uh,
right?
yes, yes. Right. So, in the last class, we were deriving these kinematic equations, 4 equations. V equal to u plus at, v square equal to u square plus 2as, s equal to ut plus half at square, Sn equal to u plus a by 2 into 2n minus 1. And fifth one, u plus s equal to u plus v by 2 into t. And I told you to first of all by heart these 5 equations. Then, after remembering them, you should understand what equation gives you which quantity. Not just remembering is not enough. So just remembering the equations, remembering the formulas will not help you in solving the questions. You should understand which equation relates which quantities and which quantity is not present in a particular equation, which quantities are present in a particular equation. You should understand these things. Then only you can apply them to solve questions. Solving questions is very, very essential based on these equations. It is a very basic kind of topic. When you start learning physics in class 11, this will be a very fundamental thing for you, applying kinematic equations to solve questions. Okay. If you had gone through these derivations in your vacation, it would be better. It would have been better. Okay. But anyhow, we need the formulas, actual formulas. Right. Now let us see how to solve questions using these equations. To solve questions, you must understand these equations, not just remember. You must understand these equations. Half at square u plus a by 2 into 2n minus 1. Okay. In questions, some terminology is frequently used, like suppose if it is said in the question, a body starts from rest a body starts from rest, then this means the initial velocity of the body is 0. If it is starting from rest, initial velocity of the body is 0. In the question, if you read this statement, it indirectly it is given to you that u is equal to 0. Then in the question, if you find a body stops or comes to rest, then this means final velocity of the body is 0. Indirectly it is said that if a body stops or it comes to rest, then indirectly its final velocity value of v is given to you, which is 0. Okay, then you might be remembering clearly, very clearly, what is uniform motion, what is non-uniform motion. Velocity is constant, uniform. Velocity is changing, non-uniform. Velocity changes, acceleration is there. Acceleration can be positive if velocity increases. Acceleration will be negative if velocity decreases with time. Acceleration, retardation. Right. Then suppose you have a question like this. A body starts from rest and travels in a straight line for 4 seconds with uniform acceleration 2 meter per second square. Find number 1, its displacement in 4 seconds, its displacement in 4th second, then final velocity. We want these 3 things. Okay. See. So step 1, while solving questions, read the problem statement carefully and try to understand the given situation. Then, if it is possible, make a figure of the given situation. Try to represent the given quantities in the form of a figure, and that figure should roughly represent the given situation. Then identify what quantities are given and what quantities are to be found out. Then identify the relation which relates given quantities with which relates known quantities with unknown quantities. Then substitute the values, do the calculations, simplifications, get the result. This is the standard procedure in problem solving. I think we should better note down this process, because this is a universally applicable procedure to solve any problem, not only in physics, in any subject, mathematics or chemistry, wherever you have problems to solve, numericals to solve. This is the procedure that you should adopt. What is it? Problem solving method. Number 1. Step 1. What is it? Read the problem statement carefully and understand the given situation. Step 2. If possible, make a figure. Drawing a figure might not be possible in each and every question, but wherever it is possible to show that situation diagrammatically, you can draw a figure. It will give more clarity to you. So if possible, make a figure. And while drawing this figure, don't focus on drawing. Your drawing skills are not being tested here. Many students, the moment the teacher says to draw the figure, students start taking out their geometry boxes, scales, rounders, protractors, set squares, all these things. We are not in geometry class or we are not in drawing class. It should be a rough sketch. Don't bother about its neatness. Don't bother about its scale, all these things. So that figure should represent the given situation roughly. That is the point. Don't focus on the what you call the aesthetic things or geometric point of views from in that figure. It is a rough sketch. That's all. Your focus should be on the problem. Then, if you draw the figure, and in that figure, try to show all the given quantities in some way. Then, after you do that, next thing is identify the given quantities and unknown quantities. Unknown quantity or quantities. Okay. Then step 4 is identify a relation or equation or formula that relates the known and unknown quantities. Known and unknown quantities. This step is very important, and this is step number 4. The problem with many students is most of the students they skip step 1, 2, 3 and directly come to step 4. The moment they read the question, they will immediately try to search for the formula. You cannot search for the formula unless you know what is given and what is asked. Only when you identify these things, you can look for an appropriate formula. So don't directly come to step 4. Do step 1, 2, 3 carefully. Then step 4 will be easy for you. Then, after you identify that required formula, required relation, substitute the given quantities in the formula and in SI. SI means standard units. Length must be in meter, time must be in second, speed must be in meter per second, acceleration must be in meter per second square, these things in standard units. Then step 6, simplify and get result. These are the 6 steps to solve any problem in physics, particularly in general in any subject. Okay. Note this clearly and understand this clearly and follow this in every problem. If you start following this step-by-step procedure, in your initial stages while solving some first 15, 20, 30, 40 questions, then you will be adapted to it. Your brain will think in the same procedure. Right. Come back to the question. A body starts from rest and travels in a straight line for 4 seconds with uniform acceleration 2 meter per second square. We want its displacement in 4 seconds, displacement in 4 seconds, final velocity. Okay. What is asked? It's next. First of all, what is the situation here? Situation is a body is traveling in a straight line like this, and it is starting from rest. Starts from rest. That means automatically initial velocity is given to you. U is equal to 0. And let us say this body starts at time t is equal to 0. Then it is traveling for 4 seconds. This is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds. Okay. With uniform acceleration 2 meter per second square. That means throughout the journey, acceleration of the body is 2 meter per second square. Okay. Right. Now, this is the given information to you. First question, we should calculate displacement in 4 seconds. Displacement in 4 seconds. Okay. So U is given, A is given, time is given, displacement is asked. UAST. These four quantities are related by which equation?
Second formula, sir. T square.
Sir, v square minus u square equal to 2as.
Where is
Sir,
what
V
do you
equals
want
to
here?
80. Sir, V equals to U plus 80.
V is equal to U plus 80. Where is S in that V is equal to U plus 80?
Sir,
Sir,
s
V
equal
square
to
is
ut
equal
And
plus
where
to
half
is
t square, sir.
where is T in that V square equal to U square plus 2AS?
So S is equal to U.
Sir, s equal to ut plus half at square.
S equal to UT plus half AT square. You should use the equation S equal to UT plus half AT square here. To be able to identify it very clearly and immediately without any confusion or without making any mistake. That's why I told you, you should understand the four equations. Just remembering is not enough. Everyone, I think in the class, remember said that x is equal to ut plus half at square, but were you able to identify that this formula is applicable to this question? That's the point. You will understand this thing only when you understand each and every equation. First equation relates velocities with acceleration time. Second equation relates velocities with acceleration displacement. Third equation relates displacement, velocity, acceleration, time. Fourth gives you displacement in one particular second. See, it's like if I give you an example, suppose you have three things with you. You have got three things. What are they? You have an umbrella. You have a raincoat. You have a sweater. These three things are there with you. Now, this is the month of January, mid-January. Mid-January. And if you want to go out, which thing will you
Sweater.
carry with you?
Sweater.
You will carry a sweater. Why? Because you are able to tell sweater, because the reason is, you know that in India, January is the month, time of peak winter, and when in winter you can protect yourself by wearing a sweater. Raincoat and umbrella will not help you. You know that January is winter and you know what is the nature of this sweater. Then only you will say that sweater is to be used in January. If it is the month of April, which will you carry with you? Will you take an umbrella or a raincoat or a sweater while going out?
Sir, umbrella, sir.
Why?
Sir, there will be so much of heat.
Yes, sir.
Because we know that April is peak summer in our country, and you can protect yourself by using an umbrella. Raincoat and sweater will not help you in April. They are useless. And if it is the month of say July,
Sir, rain.
what will you carry?
Raincoat.
Raincoat because of
Why?
rain, sir.
July is
And
the monsoon
umbrellas.
season. July is the monsoon season. Chances are raining are there. So you can carry a raincoat to protect yourself, or you can carry an umbrella also. Umbrella will also protect you from rain. So you can use two things here. Similarly, you will identify, you can understand which equation to be used for which problem only when you understand the nature of that equation. You know that umbrella protects you from rain, raincoats protects you from water, sweater protects you from cold. Then only you are able to answer these things. So in the same way, you should understand the nature of each and every equation. What quantities are related by that particular equation, you should understand that. Then only you will be able to use the correct relation. Otherwise, you will be going on all trial and error basis, which will be wasting your time. So here, U, A, T, S, these are related with S is equal to UT plus half AT square. U is 0, A is 2, T is 4 square, which is
Sir, 2 to
1 by 2 into 2 into 16, which is 16 meter is the answer. So in 4 seconds, the body will cover a displacement of 16 meter. Okay. First question. Second question. Its displacement in 4th second. Displacement in 4th second. I told you, I think 2 or 3 times, the difference between third equation and fourth equation. Third equation gives you displacement in an interval of time. Fourth equation gives displacement in one particular second. And here displacement in 4th second is asked. So we should use Sn equal to u plus a by 2 into 2n minus 1. We want it in 4th second. So in place of n, we put 4. U is 0. A is 2. N is 4. 2 into 4, 8 minus 1, 7. So it covers 16 meter in total 4 seconds. And out of that 16 meters, 7 meter in the 4th second, last second of its journey. Third question. Final velocity. Final velocity. The body is starting from rest at t equal to 0 and is traveling for 4 seconds. So final velocity is velocity at 4 seconds. How much is this velocity?
V, sir.
We have u, we have a, we have time, and we want v. U, v, a, t. These
Sir,
are
V
related by
equals 80.
first equation, v equal to u plus 80, which is 0 plus acceleration 2 into time 4, 8 meter per second. So its velocity will be 8 meter per second. Or you can do this same thing in another way also. What is that? I will use second equation.
Sir, transpose.
V square equal to u square plus 2as. Here v square is equal, u is 0 plus 2 into acceleration is 2 into displacement. We have got the displacement here,
16.
16 meter. 16 meter. So I will put 16 here. So v square is 16 into 4, 64.
Root. Sir, root of
That means
64.
v is 8 meter per second. You will get the same result. So it's like using umbrella in April and July. Anyone can be used.
Sir,
Yes.
Sir, how to find the direction of the displacement, sir?
It depends on initial and final positions. If positions are given to you, then you can find it. You can express that in the form of vectors.
Okay, sir. If the positions are given, then do we have specific formula, sir?
Final position minus initial position will give you displacement.
No, sir, for the direction.
For direction, to determine direction, you need the initial velocity must be given in direction. Like instead of giving directly magnitude, it must be given in vector form.
Okay, sir. Thank you, sir.
Next question. You have to do this. When brakes are applied, velocity of a car changes from 40 meter per second to 10 meter per second in 10 seconds. Acceleration produced in it is. Do this, all of you. How many of you have done? One, two, three. Let's see. First of all, read the statement carefully, understand the given situation, and if possible, show it in the form of a figure. Again, a car. What is this car? Yes, a car is. Brakes are applied to a car which was moving at 40 meter per second, and its velocity becomes 10 meter per second in 10-second time. What is acceleration produced? So, a car which was moving with initial velocity 40 meter per second at time t equal to 0, brakes are applied which will reduce the velocity of the car, and in a time of 10 seconds, the velocity of the car becomes 10 meter per second. That means this is its final velocity. This is its final velocity. What is the acceleration produced? U is given 40 meter per second. V is
Sir,
given
minus 3, sir.
10 meter per second. Time is given 10 seconds. What is asked? Acceleration is asked. U, V, A, T. These are
V equals to
related.
U plus 80.
Sir, V is
V
equal
is
to U
equal
plus
to U
80.
plus 80. From this, we need A, which is V minus U by T. V is 10 minus U is 40 divided by time is 10. So this is minus 30 by 10, which is
Sir,
minus
minus
3
3,
meter
sir.
per second
3
square.
meters retardation.
Minus sign indicates that velocity is
3 retardation.
Sir, 3 retardation, sir.
oh. So the acceleration produced is -3 or retardation is 3. If you say retardation, we should not use minus because retardation itself means negative acceleration.
Sir,
Yes.
sir, instead of in the answer in the solution, instead of writing v equals to u plus t, can we directly write a equals to v minus u by t?
Yes, you can write.
Okay, sir.
Next. Body moving with initial velocity 3 meter per second moves with acceleration 2 meter per second square. Then distance traveled in the fourth second is distance traveled in the fourth second is make a habit of drawing a figure. It will help you to understand the question better. So body, something, car, bus, something is moving with initial velocity 3 meter per second. U is 3 meter per second. Acceleration 2 meter per second square. Distance travel, it starts at time t equal to 0 and it moves for 4 seconds. Then what is the distance traveled in fourth second? This is third second, this is fourth. So distance traveled in fourth second will be this. The moment you see fourth second, second second, seventh second, nth second, you should understand that you have to use the fourth equation. U is given 3 meter per second. A is given. N is given 4. S is to be calculated. So Sn equal to U plus A by 2 into 2n minus 1. S4 is equal to U is 3. A is 2. N is 4. 3 plus 8 minus 1, 7, which is 10 meter. Next question.
Sir,
Yes.
sir, S represents displacement, no, sir?
Yes, displacement.
Sir, then he asked distance, no, sir?
If a body is moving in a straight line without changing its direction, displacement and distance will be same.
Okay, sir. Thank you, sir.
Next question, this one.
Sir, once could you move, scroll up? Sir, done, sir.
A body starts from rest and moves with constant acceleration. Find the ratio of its displacements in sixth second and sixth second. What is given? Body starts from rest, u equal to 0. Moves with constant acceleration. A is some value, a equal to constant. Value is not given. Ratio of displacements in 6 second and 6th second. So t is 6 seconds and n is 6. So we want ratio of displacements in 6 second and 6th second. Displacement in 6 second is s is equal to ut plus half at square. And displacement in nth second is Sn is equal to u plus a by 2 into 2n minus 1. We want this ratio S to Sn. U is 0, so it will be half a t square by a by 2 into 2n minus 1. A is cancelled, 2 is also cancelled. You have t square by 2n minus 1. T is 6, so 6 square 36 divided by 2, n is 6, 2 into 6 minus 1. So this is 36 by 12 minus 1, 11. 36 by 11 is the ratio. Okay. So these are some basic questions. Tomorrow we will do some more questions. Yashwant. Yashwant Sai Charan. Okay, right. So tomorrow we will continue. We will do some more questions on
Sir, I
this.
have a doubt.
Uh,
Sir, here we should find the displacements in 6 seconds and 6th second, no, sir?
yes.
Sir, this is you only find it out 6th second, no, sir?
What do we have in the numerator? Ut plus half at square.
Yes, sir.
Oh.
Yes, sir.
In the numerator, it is displacement in 6 seconds. Denominator,
Yes,
it is displacement in 6th second.
okay, sir.
Right. So
Thank
after the class, you once again go through the questions. You will get more clarity. All of you go through the questions once again. We will continue tomorrow.
Thank you, sir.
Bye, sir. Thank you, sir. Good night.